Okay, we are skipping section 3.4 of the book and going on to section 3.5 of the book, which is continuous distributions. So topics to take notes on are probability, which is going to be the area under the curve. For continuous variables, we're talking about the range of values and no single value. And that's it. That's what you need to take notes on for this section. So this is another really quick section. So continuous distribution. Below is a histogram of the distribution of heights of US adults. The proportion of data that falls in the shaded bins gives the probability that a randomly selected US adult is between 180 and 185 centimeters, so like between 5'11 and 6'1. Okay. Since height is a continuous numerical variable, its probability density function is a smooth curve. So we could kind of create the smooth curve that tells us the probability density function. Okay, so therefore, the probability that a randomly sampled US adult is between 180 and 185 can also be estimated as a shaded area under the curve. Okay, so the area under the whole curve is 1, representing probability 1. And then if we look at the area underneath certain sections, that tells us the probability of a randomly chosen person being between those heights. So since continuous probabilities are estimated as the area under the curve, the probability of a person being exactly 180 centimeters is defined as 0, okay? Now, this might sound silly because, lots of people would say that they're 180 centimeters, but we tried to make it a continuous variable, which means any single person is not going to be exactly 180. They could be like 180.001 or 179.99. And so you only allow non-zero probabilities when there's a range of numbers, when we're dealing with a continuous variable. Okay, that's it. That's this section. This section is getting you ready for the next section when we talk about the normal curve. Okay, so that's it for here.